Integrals is a part of calculus. Mostly one would start studying in high school. Calculus in general is notoriously known for being difficult. I believe there are a couple of reasons for that. One being, yes, it needs out of the box visualization and deep thinking. But I believe the main reason is our education system. In our education system, it's never taught why one has to study calculus or what is a real scenario where calculus is useful. Today, I'll make an effort to give a basic idea of calculus, particularly integrals with real life example. Let me start with something very simple, which everyone knows. You might have studied in a primary school. Finding an area for basic shapes like a circle or a square or a triangle. You can apply a formula for a circle like pi r square and find an area of circle. So and so for square and triangle. But how will you find an area of an irregular shape? For example, how will you find an area of shape something like this? There is no formula which you can apply. I can quote more complex examples. Find a vertex of a ball trajectory, or find a volume of a vase, or find a time taken by a rocket to reach moon. They are all very hard problems to solve. And you can guess, yes, calculus has a solution for all these problems and plays an important role in our day-to-day life. So what is calculus? Let me start with a simple example which will give a underlying principle and basis of calculus. You will get an idea how calculus helps us to solve a complex problem. Let me take a rested car and it moves about 5 seconds and we'll calculate the total distance traveled by a car. Very simple problem, right? Car travels for 5 seconds and we have to find the total distance. Seems very simple to me. So driver gets onto the car, starts driving. After 1 second, his speed is 1 meter per second. After 2 seconds, his speed is 4 meter per second. And after 3 seconds, he speeds up the car and reaches 9 meter per second. And after 4 seconds, he reaches 16 meter per second. And after 5 seconds, he reaches 25 meters per second. You can notice one thing here. A driver is speeding up the car at t square speed. So if he is at 4th second, his speed is at 16 meters per second, and if he is at 5th second, his speed is 25 meters per second. This is a vital information in calculating the total distance. Let me put that in a simple graph. And to make it clear, let me draw a rectangle below that. So if you see, I just draw a rectangle of 1 to 5 seconds and corresponding speeds. Surprisingly, if you add an area of all the rectangles, it will give you total distance traveled by a car because it's a rectangle for each second. So you add for 5 seconds, you'll get total distance traveled for 5 seconds. Let me expand that. So base versus height. So 1 times 1 meter, 1 times 4 should be here, t square. If you add all of them, you'll get 55 meters. 55 meters is the total distance traveled by a car after 5 seconds. Very simple, straightforward math. And I don't think so there is a need of calculus here. I wish it was that simple. Unfortunately, that's not the right answer. We are not even close. Let me prove it to you. Earlier I showed a car stopping at every second and picking up a steady speed between the seconds. In reality, that's not true. In reality, car speeds up every millisecond between the seconds till it reaches 5 seconds. If you see the speedometer goes from 1 to 25. It doesn't go from 1 to 4, 4 to 9, 9 to 16. And it goes from 1 to 25. You can see all the digits. The good news is that we know at any given point what is the speed of the car. We know the rate of the change, that is t square. If I have to give an example, if you want to find a speed at 3.5 seconds, it's 3.5 square and 12.25 meters per second. So if the car is at this point, that's a bad car. Yeah, its speed would be 12.25 meters per second. So how do you find the distance? Let's do one thing. Let's chop the rectangles into a little thinner rectangle. I'll chop the 5 seconds into 10. So I will chop the rectangle into smaller, thinner rectangles and into 10 rectangles. Let's apply the same formula. Base times height, and let's see if a result changes. It should be t square here. 0.5 square, zero point 0.5 times 1 square, 0.5 times 1.5 square. So base is 0.5. And if you apply for all the 10 rectangles, you get 48.125 meters. That's definitely different than 55 meters. Seems like we are getting closer to answer, but that's not the right answer. It's different than 55 meters, but it's not the right answer. Then what is the right answer? So if you see graph closely, the total distance is the area under this curve, but there are triangles hanging on the top. So we have to get rid of these triangles. So let's chop the rectangle into further thinner rectangles. I did already some maths. So if you chop 5 seconds into 20 slices, that is 0.25 seconds, you get 44.840 meters. If you chop 5 seconds into 40 slices of 0.125 seconds, like thin rectangle, you get 43.242 meters. This answer is closer to right answer, but this is not a right answer. Where is the right answer? Right answer would be when t is almost limiting to 0, meaning you have to slice 5 seconds into almost infinite rectangles and add them. So it's not possible in our regular method. So we have reached a point where we need something else to solve this problem. That something else is calculus. In this case, we need an integral calculus. It is believed that two genius mathematicians, Sir Isaac Newton and Sir Gottfried Leibniz, gifted this beautiful concept to us to solve most complex problems of nature. If you have come this far, you have understood the real world problem, why we need a calculus, and I hope you are eager to understand how calculus works. Rest of the video is just a formality. I'll be showing annotations of calculus and how it mostly operates and solve few problems. But you have crossed a major hurdle to know why calculus is needed. If you take the earlier graph, time versus speed, you have seen the curve f of x, that is t square. Car is moving at t square speed. The way you solve calculus is, so first you write this kind of elongated s, and this is called a lower bound, and this is called upper bound. So car is going from 0 seconds to 5 seconds. So you want to find a total distance of a car which is driving at f of x speed and dt. So you take a dt is a tiny dt and f of x is a height. So you basically take a numerous rectangle and from 0 to 5 and add them. That's what it means. So if you replace f of x is equal to t square times dt. How you solve this equation? There is something called power rule. You can look into YouTube and get many videos which will explain what is power rule. It's very basic and there is a proof also. Simple math. The way you do is you take the t square and do plus 1 and divide the t by the same number. T square plus 1, divide by 3. So it is 3 and 3. And then you take this entire combination and apply to upper bound minus lower bound. So if I have to give an example, it looks something like that. It's t cubed by 3, 5 cubed by 3, and then 0 cubed by 3, that is 0. So the answer is 41.666. This is the total distance traveled by a car. You can apply this to any equation. For example, t cubed of dt. So you do plus 1 and by 4. That's what it is. And if you take t square root of t plus t, so square root is half, and you do plus 1 and half plus 1, and then this is 1, so 1 plus 1 divided by 2. So that's what you see here, t square by 2. So simple way of solving the integral equation. That's the basic of integral calculus, and that's how it is used. Thanks for watching the video.